All right, so I'd like for us to look at some of the intricacies that pertain to functions, their inverses, and their domain and range. So let's start with a function that I think we're all familiar with. So I think that you would agree with what I have here on the board. We have a quadratic function with positive orientation. Vertex at 0, 3 opens up forever. I gave you a couple of points for free just to look at. The domain is all real numbers. It goes left and right forever. The range begins here at 3 and it goes up forever. That's the lowest y coordinate. That's the highest. So now let's go off and discuss the inverse of this function. So to find an inverse algebraically, you switch x and y and you solve for the new y. I've done that for the most part, but careful. I took a square root on both sides here. Yes, I took a square root on both sides. So technically speaking, I should carry a plus or minus. But my question to you is, what do I do with the plus minus? Do I keep them both or just one or the other? Let's look at the graph of this function, if it even is a function. You see, the plus or minus gives you two pieces. The positive version of this square root function looks like this. And the negative version of this function gives you the lower half. And if you notice, we have a major issue here. You see, I would like to finish this problem by stating the domain and range. However, I cannot, because that's not a function. Remember the vertical line test? See, this is a function because it passes the vertical line test with flying colors. This does not, because at many instances, the function is hitting my arm at 2 points at the same time, and that's no good. So what we have to do is we have to make an adjustment, and this means a little more work on our end. But hang on tight, it's not going to be too bad. See, if you want to make this a function, one option is to erase either half. So it is customary for us to keep the positive half. So for that reason, I am going to throw away the bottom half. I'm going to throw away the bottom half of that. See, now it's a function. So in essence, I have wiped off the negative piece. So if I've wiped off the negative piece, that implies that I essentially keep the positive piece. And while I'm here, I should note that it should not be called y, it should be called f inverse, just to be technically sound. Now, if I've made changes to this, I should go back and make changes to that. It's only reasonable. If I knocked off half the picture here, I'd have to make an adjustment and account for there. So which half of this parabola should I keep and throw away? Well, if I'm going to keep the piece that has 7, 2, then I have to keep the piece that says 2, 7. Which would be the right half, which makes sense because this is the positive half. So I'm going to throw this away. And I'm doing this out of a reaction to what happened here. Now, if I took away half of this parabola, that means I might have to make a change to the domain here. So what I'm going to do now is react to what just happened. Now my domain actually starts from 0, and it goes to the right forever. The range is still the same. Now let's go back over here and finish this problem. What is going to be the domain of this picture? Well, how far left does it go? It goes to 3, and it goes to the right forever. What's the range? The lowest y coordinate is 0, and it goes up forever. I went through that quickly because it is expected that that concept was discussed earlier. Now, before I let you go, I want to point out one thing to you. Notice that the domain here of f is the same as the range of f inverse. Yes, these are the same. They're the same. And notice that the range of f is the same as the domain of the inverse. And that essentially always happens. And then one more thing that I can throw at you is the following. Let's say that I wanted to grab this picture and overlay it with this one here. Well, check out what would happen. So this is what this graph would look like if I were to drop it in there. And notice that if I were to graph the line y equals x, it would look something like this, that these two are reflections of each other over this line. So if I were strong enough to fold this whiteboard in half along this line, then these two would overlap perfectly like the wings of a butterfly.